Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to another video of chem-solve. Today in this video we are going to solve Cambridge IGCSE multiple choice paper 2. The code for this paper is 0620/23 May June 2025. So let's start the paper. Okay, so the first question says which two changes when applied at the same time at a fixed amount of a gas causes the greatest increase in the volume of the gas. We have to increase the volume of the gas. Okay, so what is the change? We have to change the pressure, we have to change the temperature. Now we have to change the pressure and the temperature in such a way so that the volume of the gas should be increased. So let's see what is the relationship between pressure and volume. The relationship between pressure and volume is inversely proportional. So if we want to increase the volume, we have to decrease the pressure. All right. So now I have to choose that option which is concerned with the decrease of the pressure. So these two options which are increase the pressure, they are not my option. So I'm going to cross them. Now see what is the relationship of temperature with the volume. Volume and temperature are directly proportional. It means if we want to increase the volume, we have to increase the temperature as well. So let's see option A. Option A says decrease the temperature, but we need to increase the temperature. So that's why this is not our option. We have to choose the option C, which says decrease the pressure and increase the volume. So C is my correct option. Now look at question number 2. Solid G is heated. It is then left to cool at room temperature. So it is first heated and then it is left to cool. But we are provided here with the cooling curve. So this is the cooling curve. G was the solid before. It is heated, it is melted, and now this melted solid, it is then left to cool. So 4 statements about the cooling curve between X and Y are listed. So let me label my cooling curve. It means it would be liquid here and it would be solid here. Okay, in liquid, you know, the particles are a bit further away, and in solid, they are closely packed. So let's see. The speed of the molecule of the G decreases. When the molecule condenses and they changes their state of matter from liquid to the solid, they come closer to each other. That's why their speed must be decreased. So this statement is correct. The molecule of the G becomes less closely packed. Molecules are more closely packed when they are converted into solid. So this is the wrong statement. Thermal energy is released by the molecule of the G to the surrounding. In liquid, the molecules are further away, they are moving, so they have a lot of kinetic energy. But in solid, there are only vibrational motion and particles are more closer to each other. So that's why when they come closer to each other, their kinetic energy decreases and the extra heat is released to the surrounding. So that's how this is the correct statement as well. G changes from solid to liquid. We just mentioned it changes from liquid to solid, not solid to liquid. Okay, so liquid to solid. That's why this statement is also wrong. That's why 1 and 3 are the correct statement and B is the correct option. Okay, question number 3. Which atom has twice as many as neutrons as protons? Twice neutrons as proton. The number of neutrons should be twice that of the proton. Okay, let's see. For the first one, it has proton 1, electron 1 and neutron 0. Because Neutron we get by subtracting the atomic number from the mass number. For 2, proton is 1, electron is also 1, and neutron is 2 minus 1 is also 1. For this, proton is again 1, electron is also 1, and neutron is 3 minus 1, 2. And for this, proton is 2, electron is also 2, and neutron is 4 minus 2, 2. So this C is our correct option because proton is 1 and neutron is 2. So neutrons are twice as many as protons. That's why C is the correct option. What is the nucleon number of an atom? So what is the definition of the nucleon number? Let's see. Nucleon numbers are the number of proton and neutron in the nucleus of an atom. Now keeping this in our mind, the number of the electron, of course not. Electrons are revolving around the nucleus into the shells. The number of the neutron and the proton in the nucleus, exactly it matches with our definition. So this is the correct option. Let's see the other option as well. The number of the neutron in the nucleus, neutron plus proton. So this is wrong. Number of the proton in the nucleus plus neutron. So this is also wrong. Question number 5. The diagram shows the position of the element P and Q in the periodic table. Okay. So P is in group 2. So it would have the charge positive 2. While Q, it is in group 7. So it would have the charge minus 1. Now keeping this in my mind, P is positive 2, Q is minus 1. When we have to form the compound, then the charges come down like this. So P would be 1, no need to write it, and Q would be 2. Did you understand? This one will come here and this 2 will come here. So it is PQ2. So the correct option is option C. Okay, now the next question is question number 6. Which statement about ionic compound is correct? We have to look for the ionic compound. Okay. So, giant lattices are formed when the ionic compound crystallizes from the solution. Yes, ionic compound are the giant lattice, and when we crystallize them from the solution, we get the solid. So it would be a giant lattice. I believe this is the correct option. No need to write, look at the other option. But if you want, I can just have a look on them. In an all ionic compound, the metal ion have the fewer electrons than the non-metal ion. It is not like that. Electron could be less for the metal, more for the non-metal, or more for the metal, or less for the non-metal. This is not the case here. In giant lattice, ions of the same charges are closer together. No. Ions are held together through electrostatic force of attraction. And electrostatic force of attraction, electrostatic force of attraction always arise between oppositely charged ions. So same charge wouldn't become closer to each other. Instead, the opposite charge will come closer to each other. So this is wrong statement. When ionic compound melt, strong intermolecular forces are broken. Not at all. Intermolecular forces are in covalent compound. While in ionic compound, we say electrostatic force of attraction. So this is a wrong statement as well. Okay, question number 7. The equation for the reaction between the iron 3 chloride and sodium hydroxide is shown like this. And we have to write the ionic equation for that. I hope you maybe remember that we have recorded a full lecture of ionic equation in our previous videos. So you can have a look on it if you want. But I can recall the concept here. When we are forming the ionic equation, what we do, we ionize only the aqueous solutions and we do not ionize the solid, metals, gases or liquids. So this would be ionized, this would be ionized, this wouldn't be ionized, and this would be ionize. So let's see. Fe positive 3 plus 3Cl minus 1 plus 3Na positive 1 plus 3OH minus 1 gives us Fe positive 3. Sorry, this is solids, this wouldn't be ionized. So FeOH thrice will be left as such, plus 3Na positive plus 3Cl minus 1. Now the same ion would be cancelled out. 3Cl minus 1, 3Cl minus 1, 3Na positive, 3Na positive. We are left with Fe positive 3 plus 3OH minus 1 gives us Fe OH thrice. The state symbol will remain same as in the main chemical equation. So aqueous and solid, it exactly matches with the option B. So option B is the correct option. Okay. Question number 8. A compound is analyzed and found to contain 85.7% of carbon and 14.3% of hydrogen only. So what I have to do, I have to find out the empirical formula. Let's find it out. What is the process? We have already done this in mole series. You can revise it if you want it in detail. So carbon and hydrogen only. Carbon is 85.7, hydrogen is 14.3. What is the next step? We have to divide them on their MR. So this is divided by 12, this is divided by 1. It would be 14.3 and it would be 85.7 divided by 12. So let me solve it. 85.7 divided by 12. This is 7.14. So 7.14. What is the next step? We have to choose the smallest answer and we will divide everything on that smallest answer. So 7.14 is the smallest. It would be divided like this. So this is 1 and we have to divide that. 14.3. 14.3 divided by 7.14. This is 14.3 divided by 7.14. So this is 2. That's how C is 1, no need to write it, and H is 2. So the correct option is option B. So the next question is again from the mole series. Aqueous barium hydroxide react with dilute nitric acid. We need equation for that. So let me write the equation. I would write the equation over here. Barium hydroxide dilute nitric acid. So this is HNO3 and will form barium nitrate, that is BaNO3 twice plus 2H2O. That's it. This is our equation. Okay, so the formula we are going to use here is acid is equal to base. M1V1 over N1 is equal to M2V2 over N2. M1 is the concentration of the acid. So let's see what is the concentration of the acid. We have to find out the concentration of the acid. So M1 is unknown. V1 is the volume of the acid. So that is 20 over here. N1 is the number of mole of the acid used in the balanced chemical equation, that is 2 over here. M2 is the concentration of the base, that is 0.75. V2 is the volume of the base being used, that is 15.2, divided by number of moles of the base in the balanced chemical equation, that is 1 over here. So that would be 10 M1 is equal to 0.75 multiplied by 15.2. 15.2 multiplied by 0.75. This is 11.4. So it would be 11.4. So I need M1. M1 would be 11.4 divided by 10. 11.4 divided by 10. This is 1.14. So my answer is 1.14. That is the option C. So, question number 10. Which particles are responsible for the transfer of the charges in the external circuit? And external circuit in the electrolysis is the battery. Okay. So, electrolysis of the molten lead bromide. Whenever we perform electrolysis, we have our electrolytic cell, then we have our electrodes. These electrodes are joined through a battery. Here is our electrolyte. So within the circuit, in internal circuit, we have ions, and in the external circuit we have battery. You can say we have electrons. So the correct option would be electrons. Now question number 11. Two statements about the hydrogen are listed. Hydrogen is used as a fuel. When hydrogen burns in the air to form water, thermal energy is produced. This question is about hydrogen oxygen fuel cell. So both options are correct, of course. That's why statement 1 is correct, but statement 2 is not correct, is incorrect. Statement 2 is correct, but statement 1 is not correct, it is incorrect, because both options are correct. So we have to choose between A or B. Statement number 2 is explaining that how hydrogen uses in hydrogen oxygen fuel cell. And when it is used in a hydrogen oxygen fuel cell, so obviously hydrogen is used as a fuel. So we can say statement 2 explain the statement 1. So A is the correct option. Concentrated, in question number 12, concentrated aqueous copper chloride is electrolyzed using the carbon electrode. What is formed at each electrode? So let's do this. Concentrated copper chloride. So CuCl2. If I ionize my electrolyte, it would be Cu positive 2, 2Cl minus 1. And of course, it is a solution, so I have to include water as well. That is H positive and OH negative. We have two positive ions. They are Cu positive 2 and H positive 1. We have two negative ions. They are 2Cl minus 1 and OH minus 1. Now look at concentrated. So in positive ions, we have to choose always that is at the bottom of reactivity series. Always we choose that positive ion that is in the bottom of the chemical series, reactivity series. So in our case, that would be Cu positive 2. And if your solution is concentrated during electrolysis, then never choose OH minus 1. This is a tip. Never choose OH minus 1. So I will not choose OH minus 1. So my option would be 2Cl minus 1. So at cathode, that is negative electrode, and at anode, that is positive electrode. At cathode, positive will go, and that is copper positive 2. It will get reduced and will form copper. At positive electrode, negative will go, it will be oxidized and it will form chlorine gas. So cathode, copper will be formed, and at anode, chlorine will be formed. So that's why B is the correct option. Now move towards question number 13. Which row describe an exothermic reaction? Okay, sign of enthalpy change. We know that for exothermic reaction, the sign of enthalpy change is always negative. Delta H is always negative. That's why positive, positive, these two options are not our options. We have to choose between C or D. Okay, this is correct. This is correct. Temperature of the surrounding. Exothermic reactions releases heat. To the surrounding. So temperature would increase, of course. So this, which says that temperature decreases, this is not our option. We have to choose temperature would increase. So that's why D is the correct option. Now look at question number 14. A reaction pathway diagram is shown. Which row shows the correct labels for X, Y, and the type of chemical reaction taken place? Okay, first of all, I will see that what is the type of the reaction that is being taken place. Reactant are at low energy state and product are at high energy state. So this is for the endothermic reaction, when reactant have to absorb the energy. That's why they are at the low energy state. So this reaction is endothermic. So I have to choose endothermic or endothermic. So exothermic is incorrect, exothermic is incorrect. That's why A and C are not our option. I have to choose between B or D. X is activation energy and Y is delta H, enthalpy change. So X is activation energy, Y is enthalpy change. That's why the correct option is option B. In option D, they have been switched. So this is wrong. So question number 15. The rate of reaction between magnesium and dilute hydrochloric acid is increased by increasing the concentration of the acid. We have increased the concentration of the acid. So whenever we increase the concentration of the acid, what happens? The particles come closer to each other. When the particles will become closer to each other and they will be more crowded, then there would be obviously more chances of collision. So the collision rate of the particles would increase. So that's why the option which says it stays the same, these are not our option. We have to choose the options which say that the collision frequency increases. Okay, makes sense. When particles come closer to each other, they are more concentrated, obviously there are more chances of collision. Okay, what about the proportion of the particles with the sufficient energy to react? This is the case only with the catalyst. Catalyst lowers the activation energy. So at that condition, what happens? More particle would be available which have the sufficient energy than the activation energy. So for concentration, what happens? It remains same. It doesn't increases. So B is the correct option. Question number 16. The reaction between aqueous iron 3 oxide and aqueous thiocyanate ion is reversible. Fe positive 3 is yellow, thiocyanate is colorless, and the product is red. Okay. So what happens at equilibrium? The concentration of the Fe positive 3 SCN and FeSCN2 ions are identical, and the mixture appears orange. When all the concentration are equal, then the mixture appears orange. Okay, when a few drops of the aqueous thiocyanate ions are added to the mixture, now we are increasing the concentration of this. Its concentration is increased. Always remember, when we disturb the equilibrium and we increase the concentration of reactant, reaction move forward. And when concentration of the product are increase, reaction move backward. So in this case, we are increasing the concentration of one of the reactant. That's why the reaction will move, the equilibrium will move towards forward direction, towards right. So more FeSCN positive 2 will be formed. That's why the solution will appear red. The correct option is option D. So question number 17. The equation for the reaction between iron 3 sulfate and bromine is shown like this. Identify the oxidizing agent and the reducing agent. Okay. So always remember, oxidizing agents reduces themselves. They oxidizes other and themselves they are being reduced. While reducing agent, they reduces other and oxidizes itself. Now, if I have to identify the oxidizing agent, then I will see that which thing is being reduced. That is the oxidizing agent. And if I have to identify the reducing agent, then I will see which thing is being oxidized. That would be the reducing agent. Okay. So here iron is positive 2, bromine is 0. Now here iron is positive 3 because of this. And bromine is -1. So iron changes from positive 2 to positive 3. Increase in oxidation number is oxidation. So iron is being oxidized. That's why it is a reducing agent. While bromine changes its state from 0 to Br -1, this is reduction. So it is reduces by itself. So it is an oxidizing agent. So bromine is our oxidizing agent and iron is FeSO4 is our reducing agent. So that's why correct option is option A. So look at question number 18. The equation represents a redox reaction. What is the change in the oxidation number of iron in this reaction? We have to look for the oxidation number of iron only. Okay, let's see. Iron is Fe2O3. It's mean iron is positive 3 here and oxygen is -2. So iron is positive 3. And here iron is alone. When something is alone, it is in free state, the oxidation state is 0. So it changes from positive 3 to 0. That's why the correct option is option D. So question number 19. Aqueous ammonia forms an equilibrium with the water. In this equilibrium, which particle act as an acid and which particle act as an base? Okay. So what is happening? Hydrogen is, water is donating H positive. And the substances which donate their H positive, they are acid. Look, water is changed from H2O to OH minus 1. One H positive is being removed. So water is for sure is acid. And the other thing must be the base. So that's why the correct option is option C. Now look at question number 20. Which row identify the acidic oxide, basic oxide, amphoteric oxide? Always remember, acidic oxides are non-metallic oxide. Basic oxide are metallic oxide. And amphoteric oxide, for them you have to remember zinc oxide, lead oxide, aluminium oxide. Okay, let's see. This is metallic oxide, so this is not acidic. This is also metallic oxide. Amphoteric, it is not acidic. So we have to choose. This is non-metallic, so acidic. This is non-metallic, so acidic. For basic, we have to choose the metallic oxide. So this is metallic. This is amphoteric. So this is not correct. And for amphoteric, we have only these three options. So Al2O3 is present. That's why D is the correct option.